Welcome to a screencast on an introduction to enthalpy. When a chemical reaction occurs, energy is either given off or released by the reaction, or energy is taken in or absorbed by the reaction. For example, in an acetylene torch, acetylene combusts. It produces a lot of energy during that combustion process, and in fact it produces so much energy that it can be used to weld railroad ties together. A chemical cold pack containing ammonium nitrate that dissolves actually takes in or absorbs energy, and this can actually be used to cool down or ice an injury and reduce swelling. Now, chemists use something called enthalpy, which we symbolize by the letter H, to follow or to track energy changes during chemical reactions. We should note that technically enthalpy is heat flow at constant pressure, but most of the time we do reactions at constant pressure, so we can normally just think of enthalpy of reaction as the heat or energy of reaction. And it's important to note that enthalpies are as integral a part of a chemical reaction as the reactants and products, and they're treated quantitatively in the same way as the amounts of the substances involved. And we'll see this in an example shortly. Okay, so let's start by considering the thermochemical equation for the complete combustion of acetylene. And here is the chemical equation for the complete combustion of acetylene. And acetylene is C2H2, reacts with oxygen to make CO2 and H2O. And this equation is correctly balanced, but it doesn't show the energy that's involved in this reaction. So it turns out that 2,600 kilojoules of energy are given off when 2 moles of acetylene reacts with 5 moles of oxygen and makes 4 moles of carbon dioxide and 2 moles of water. So this is now a thermochemical equation, and it shows that heat is a product of the reaction, and it shows explicitly how much heat is a product of the reaction. Now there's another way we can write this, and that is to write the chemical equation as we did before, but instead of showing the energy as an explicit product, we write the enthalpy change, delta H, and the delta H, the enthalpy change for this reaction, is negative 2,600 kilojoules, and the reason for the negative sign is it indicates that energy is given off. This is what's called an exothermic reaction, and all exothermic reactions give off energy, and all exothermic reactions have a negative value for delta H. Okay, now let's see how we can use this quantitatively, and let's calculate the enthalpy change when 0.473 moles of acetylene burns and see what it means. Well, here is the thermochemical equation, and if we have 0.473 moles of acetylene, we note that what the thermochemical equation tells us is that 2 moles of acetylene will produce 2,600 kilojoules of energy. We put a negative sign on the energy or the enthalpy change because energy is given off. And then note this conversion factor converts from moles of acetylene into kilojoules of energy. And if we do the calculation, we get negative 615 kilojoules for the enthalpy change. 615 is the quantity, 615 kilojoules, and the negative simply means energy is given off. So in words, we would say what this means is that this amount of acetylene, when it burns, gives off or produces 615 kilojoules of heat. Okay, let's also do a thermochemical equation for the ammonium nitrate dissolving in water in a chemical cold pack. Here is the chemical equation. It's actually just a dissolving process, but solid ammonium nitrate, when it is dissolved in water, produces ammonium ions and nitrate ions, and it turns out that actually takes in energy. And it takes in 25.7 kilojoules of energy, or heat, when 1 mole of ammonium nitrate solid dissolves. So here's one way of writing the thermochemical equation for this process, and the other way involves using enthalpy, or enthalpy change, like we did previously, And so we write the chemical equation. NH4NO3 solid makes NH4 plus and NO3 minus aqueous. And then we tack on the delta H, the enthalpy change value at the end. And here, 25.7 kilojoules of enthalpy is the change, but it has a positive sign because in this case, energy or heat is taken in during the process. And this is an example of what's called an endothermic reaction. All endothermic reactions take in energy, and all endothermic reactions have a positive delta H value. And let's do a calculation with this. What's the enthalpy change when 40.0 grams of ammonium nitrate dissolves? And what does this mean? Well, there's the thermochemical equation. And again, note the chemical equation, or thermochemical equations, like chemical equations, are based upon moles. So we have to convert the 40 grams of ammonium nitrate, I'm using that as a shorthand for it, using the molar mass of ammonium nitrate to get the moles. And now we note this is a simple stoichiometry. For every 1 mole of ammonium nitrate that dissolves, 25.7 kilojoules of energy are absorbed, so that's positive. That converts from moles of ammonium nitrate into enthalpy change, and that turns out to be 12.8 kilojoules, and it's positive. So what this means is when 40 grams of ammonium nitrate dissolves, 12.8 kilojoules of energy or heat is absorbed. And that is it for the introduction to enthalpy.